Hello bachcho, let us read the question. A long solenoid of radius A and number of turns per unit length N is enclosed by cylindrical shell of radius capital R, thickness D, where D is much less than R, and length L. A variable current I equal to I naught sine omega t flows through the solenoid. If the resistivity of the material of cylindrical shell is rho, find the induced current in the shell. तो इस क्वेश्चन का की कॉन्सेप्ट है इलेक्ट्रोमैग्नेटिक इंडक्शन. इलेक्ट्रोमैग्नेटिक इंडक्शन. तो the current produced due to a current produced due to an electromotive force caused by a changing magnetic field. तो जब भी एक ऐसे सिचुएशन होता है, it will produce a current, the electromotive force will produce a current which will oppose the cause for its induction. तो इस phenomena को electromagnetic induction कहते हैं. Changing magnetic flux या changing magnetic field. So since this is a solenoid, so magnetic field of a solenoid is given by B is equal to mu naught N into I, जहाँ पे mu naught है permeability of free space, N is number of turns per unit length, और I है current through the solenoid. तो इस क्वेश्चन को सॉल्व करने के लिए पहले हम जो डिटेल्स क्वेश्चन में दिए हैं हम उसको नोट करेंगे. Given length of the solenoid is given L. Radius of the solenoid is given to be A. Current is varying as I is equal to I naught sine omega t, and then we have radius of the cylindrical vessel, as capital R. Length of the cylindrical vessel वो है कैपिटल L. thickness of the vessel is D, और क्वेश्चन में ये दिए है कि D is very much less than R, और resistivity is given to be rho. So सबसे पहले we will see what is the magnetic field and number of turns. उसको दिए हैं कैपिटल N. Number of turns per unit length मेंशन करना है. Number of turns per unit length, that is capital N. So B is the magnetic field through the solenoid is mu naught N into I. तो अभी flux, magnetic flux is phi is equal to B into A. So A is the area of cross section of the solenoid. तो हम phi, that is the magnetic flux को, we can calculate it as mu naught N I into pi A squared. अभी I को हम substitute करेंगे as how they've given the current is varying. So this is I naught sine omega t into pi A squared. So from Lenz's law, we have the induced EMF equal to minus d phi by dt, पर हम अभी यहाँ पे सिर्फ मैग्नीट्यूड लेंगे. So this is d by dt of mu naught n I naught sine omega t into pi A squared. So this will be, तो mu naught n I naught pi A squared सब constant है, तो they will come out, they will not get differentiated. This will be d by dt of sine omega t. So therefore we get the induced EMF as mu naught n I naught pi A squared into omega cos omega t. So the induced current is given as, so induced current is I is given by E by R, जहाँ पे E है induced EMF और R है the resistance. So this is equal to mu naught n I naught pi A squared omega cos omega t whole thing divided by R. तो अभी they have given the resistivity, तो हम we will write this with small r, क्योंकि capital R को हम radius of the cylindrical vessel लिए है. So this we will write it as small r. So the resistance is given by resistance R is given by rho L by A. So L is essentially the length through which, length of the vessel through which current flows. So that is given by 2 pi capital R, and A is area, cross-sectional area or area of cross-section through which current flows, and that is given by capital L into D. So therefore resistance अभी हम लिख सकते हैं rho into 2 pi r divided by L into D. So the induced current is now mu naught n I naught pi a squared omega cos omega t divided by rho into 2 pi r divided by L into D. So हम final expression for the induced current लिख सकते हैं mu naught n I naught omega into cos omega t into pi a squared divided by rho into 2 pi r. So this is the expression for the induced current. Hope you have understood it well. Best of luck.